In this video, we are going to discuss about the domain theory of ferromagnetism. Now, as you all know, the atom of the ferromagnetic materials, they possess non-zero magnetic moment due to the spin motion of the unpaired electrons of the atoms. Now, Weiss postulated that the atomic dipole of an atom, they strongly interacts with the neighboring atom by a quantum mechanical interaction called exchange interaction. In the previous video, I have shown that the dipole moments of the ferromagnetic material, they are arranged parallel to each other. Now, according to Weiss, they interact with each other via quantum mechanical interaction, and the name of this interaction is exchange interaction. Now, due to this exchange interaction, a large number of dipoles spontaneously, I repeat spontaneously, they align themselves in the same direction over a volume of the material. Hence, each domain is magnetized. These small regions over which this alignment takes place is designated as domain. So, each domain is magnetized to a saturation stage. Thus, the ferromagnetic material exhibits spontaneous magnetization even in the absence of an external field. The small volumes of uniform magnetization of a ferromagnetic material, they are called the domains. Therefore, the definition of domain is: the domain is a small volume of material that consists of large number of atomic dipoles which are held together by a force of exchange interaction. You see, this domain, that means each and every domain is magnetically saturated. Why? It is due to the alignment of all the magnetic dipoles in the same direction. The direction of magnetization in different domains is different. The size of the domain is extremely small. It is around 10 to the power minus 8 to minus 12 cubic meter. And yet each domain contains a large number of atomic dipoles. The boundary which separates two domains is called the domain wall. The magnetic domains within the material are so arranged that the direction of magnetization varies from domain to domain, and such that the magnetic effect of one another is nullified. You can see in this picture, there are 4 domains here. I have drawn a schematic diagram. Now, the net magnetization of each domain is shown here, and you can see here that all the magnetization nullifies each other. Therefore, the sample is in the demagnetized state. Now, if we talk about the magnetization, when an external magnetic field is applied to this ferromagnetic material, the substance becomes magnetized. And this magnetization is observed due to 2 things. One, the magnetization occurs by the motion of the boundaries, that is the displacement of the boundaries, and this happens when the external field is weak. And another is when the external field is strong, the rotation of the domains in the direction of the magnetizing field takes place. In this picture, I have shown here that when a strong magnetic field is applied, how the rotation of the domains takes place. This is domain A and domain B. You see, they are completely in the opposite direction, and how the rotation is taking place. So, this is all about the domain theory.